arithmetic series question. So the bit in yellow that you can see on the right hand side there is just a snippet from the formula book of the formulas for arithmetic series and geometric series. So what have we been told? We've been told that the sum of the first 21 terms is 168. Show that a plus 10d equals 8. So we're going to have to use the sum formula, and we're looking at something with the first term and the common difference. So I'm likely to be using the second sum formula, which is the one that involves common difference and first term. I don't want to be using the first form where you've got last term. So we are going to be using the sum of the first 21 terms. So n here is 21. So it's a half of 21. And all of that is multiplied by 2a. We don't know what a is, because we're just trying to show that it's a plus 10d equals 8. We do know what n minus 1 is. So let's just take our time here. 21 take away 1 times by d, and we don't know what d is either. But what we do know, using this formula here, is that that is equal to 168. So half of 21, so 10 and a half, or 21 over 2, multiplied by 2a plus 20d, and all of that is equal to 168. So we must be close here, show that a plus 10d equals 8. So we want to try and get all of our a and our d on the left hand side and just a number value on the right hand side. And again, I'm just going to take my time with this. So I'm going to rearrange this, multiply both sides by 2 to start with. So I've got 20d here, and I'm multiplying 168 by 2. So just onto my calculator. Still got some workings from a previous question on there. 168 times 2, just in case I've forgotten how to do that, or I can't work that out myself. I have got the calculator to tell me that's 336. Then I'm going to divide by the 21. Okay, so divide both sides by 21. So 2a plus 20d equals, let's go back again, 16. Now, is that what I was after? I was after a plus 10d equals 8. So I still need to, at this stage, divide by 2 to give me a plus 10d equals 8. Now, there's probably enough there to convince my examiner that I've done that, show that correctly. What I would say is a good idea is, if you remember back to when you first were solving equations, you were doing things like writing on both sides. I'm timesing both sides by 2. I'm dividing both sides by 21. And I'm dividing both sides by 2. And it's almost worth doing that just to show that you are completely sure what you're doing and you've managed to get that, that correctly created. If you don't do it, as I say, you're unlikely to lose marks, but in a show that, the idea is to show the examiner that you know exactly what to do step by step. So that was part A, part 1. We're now looking at B. So I'm going to try and do it over here, just because I know I need to use what I did in A. So the second term of the sequence and the third term, sorry, the sum of the second term and the third term is 50. So U2 plus U3 is 50. Okay, find the value of the 12th term. So there's 4 marks here. Now U2 plus U3 is 50 doesn't give you any marks, but if you actually think about what that is using the first formula here, U2 is a plus n minus 1. Now for U2, n here is a 2, so 2 minus 1, which is 1d. Okay, add that to U3, which is a plus n minus 1, so 3 minus 1, which is 2d equals 50. So tidying this up, I get 2a plus 3d equals 50. So I've got that equation there. Okay, worth a couple of marks there, I think. Then I'm trying to find the 12th term. Okay, I'm trying to find U12. And in order to do that, I need to know what A and D are. So I've now got 2 equations. I've got the first one from part A plus 10d equals 80. And I've got 2a plus 3d equals 50. So using those two, I'm going to be able to solve these two simultaneously to actually be able to find the values of A and D. And once I've got that, finding U12 is really straightforward. So these are my two equations. I'll put boxes around them and call that one equation 1 and that one equation 2. So if I write out equation 1 again, double equation 2, that way I've now got two terms the same. So so that one is equation 2 times 2, and that one's equation 1. Okay, and I'm going to subtract equation 1 from double equation 2. So the A's disappear, I'm left with minus 17D, and that equals 50 take away 16, which is 34. So D is equal to minus 2. Okay, so I've divided both sides by minus 17. Again, you've got your calculator to support you if you want to check any of that or make sure that you're right. So once I've found the value of D, I can use either equation 1 or equation 2 to find the value of A. I'm going to use equation 2. So A plus 10 lots of minus 2 equals 8. So A plus minus 20, so plus minus 20 equals 8, A equals 28. So now I've got my information for my equation for UN. So let's just keep this coming down here. We're going to go over here. So UN for arithmetic series, make sure we're looking at the right one, A plus n minus 1 D. Now we just found out that A is 28, so that was down here when we subbed it in, and D was minus 2. So I'm doing plus n minus 1 times by minus 2 equals UN. Now going across to the question, so I'm jumping around a little bit here, but hopefully you can follow where I'm going with this. To find the value of U12, so U12 is where n here is 12. So U12 is equal to 28 plus 12 minus 1 minus 2. Sorry, times minus 2 there. So I've got 28 plus 11 lots of minus 2. So they're multiplied together. Remember, it's D times n minus 1. So U12 is 28 minus 22. So the 12th term in this sequence is equal to 6. Now, to finish off this question, obviously there's another part to it. I'm just going to remove all of the workings that I've done here. But what I want to make sure is that we've remembered that A is equal to 28 and that D was equal to minus 2, because those two pieces of information are really important for part 2 of B. Okay, so now we're back with a nice clean board, if you like. So I'm now looking at B part 2. Now, the biggest problem that my students had with B part 2 was actually in the very definition, the first mark needed here. We are trying to add together from the 4th term up to the 21st term of this sequence. So if we imagine looking at the terms, so we've got the 1st, 2nd, 3rd, 4th, 5th, all the way up to the 21st term and so on. So this sequence, whatever it does, we know that the first term now is 28. We worked out the 12th term was 6 and it was going down by 2 each time. But that's not important. What's important here is what we're trying to add up. We're trying to add up from the 4th term all the way up to the 21st term. So in order to do this, we need to add up, because we've only got a formula that gets from the first term onwards. So the sum formula doesn't allow us to just pick and choose where we start from. So what we're going to be able to do is we could add up all 21 terms of our sequence and subtract from that the first 3 terms, this bit here. Now, what a lot of students did was subtracted the first 4 terms. But we're including the first 4 term. That's the first term we're looking to add on. So we're going to be subtracting the 3. Drawing a diagram like this doesn't take any time at all, but it does allow us to really see what's going on. And then from here, we just need to work out what this evaluates to and what this evaluates to. So in order to do that, we're going to be doing S21 and we're going to be doing S3. Okay, the sum of the first 21 terms, the sum of the first 3 terms. Now we don't know the last term in this sequence, so we're still going to be using this second formula here. Now we know what A is, we know what D is, so we're just going to be substituting everything in. So this is equal to a half of 21. So half of the 21. 2 lots of A, which is, 2 lots of 28, plus n minus 1, which in this case is 20, times by D, which is minus 2. Now, my hesitation here was because I actually reread part A of the question, and we've already been told that the sum of the first 21 terms is 168. So if you want, as an exercise, you can convince yourself by completing this that this actually comes to 168. But if you're looking to do this in an exam, you're obviously looking to save time and have some tricks to do that. And the 168 given in the question is obviously going to help us immensely, saving a bit of time. But if you wish to, you can plug that all into a calculator, this step here, and you'll find it comes to 168. Looking at the sum of the first 3 terms then, so that's the sum of the first 21, we've already done that. Sum of the first 3, so it's the same thing again, a half of 3 this time, and it's going to be 2 lots of the first term remains the same, so it's still 28, plus n minus 1, so 3 minus 1, 2 lots of minus 2. Okay, now if we just grab our calculator, again we've got something from a previous question on there, and don't try and be too clever with it, just put it exactly as it looks, brackets in and all, into your calculator. If you do this, if you always just follow the brackets that you've used for any sort of question, you will get to the right answer. I think it's students that try to be a bit clever and make things look different will get something different. So this tells me that the first 3 terms comes to 78. Okay, now obviously there's other ways of doing this. You could say, well, the first 3 terms, 28 is the first one, 26 is the second one, 24 is the third one. But if you're using all the formulas, you know you're going to be on the right lines. And so to finish off then, we know the sum of the first 21 is 168. Subtract from that the first 3 terms, which was 78 in total, and then we are just going to quickly pop into our calculator 168 minus the 78 to get the correct answer of 90. And that's worth our 3 marks. So what I've shown you here is very much the long way of doing B part 2. If you've kind of understood how this sequence works, you might have found quicker tricks and things to get through this. But if you followed all of this, you've then worked out the full solution with full exam style workings.